Example 2. Exactly 152 yellow peas using StatCrunch. Using the same information from the previous example, we want to find the probability of exactly 152 yellow peas among the 580 offspring peas. That is, given the sample size of n, which is equal to 580, and assuming that the probability of success p is equal to 0.25, find the probability of exactly 152 yellow peas. Is this result useful for determining whether 152 yellow peas is significantly high? In our previous example, we were able to find the mean and the standard deviation. Let's go ahead and do that again. To find the mean, it's taken n times p, the sample size, which is 580, times p, which is 0.25, and that gives us a mean of 145. And then, to find the standard deviation, we're going to take the square root of n times p times q, where q is equal to 1 minus 0.25, which is 0.75. So we're going to take the square root of 580 times 0.25 times 0.75, and that gives us a standard deviation of 10.4283. So, first thing is first, let's draw our bell curve before we move any further. So we draw our bell curve. And so we want to label the mean. So we label the mean, we know that that's going to represent 145. And then we're looking for exactly 152. Okay, so now we're going to draw and label, which is what we did. We draw and label the graph of the bell curve. So let me go ahead and pull that down here. Okay, and so we draw the bell curve with a normal distribution to have the mean of 145 and the standard deviation of 10.4283. And then we're going to shade the area that approximates the probability of exactly 152 yellow peas. Now, because it's an approximation, that region is going to be the vertical strip that's between 151.5 and 152.5. And we'll show you here. Now remember, we're using the continuity correction as we represented the discrete value of 152 in the graph of the normal distribution. So remember, that means if you take x and subtract 0.5, 152 minus 0.5 gives you 151.5. So let's go ahead and label that on the graph. So that means to the left of 152, we have 151.5. Okay. And then if we put in 152 and then add 0.5, we get 52.5. So that means we're going to have a value that's to the right of 150, which is 52, which is 152.5. And then what we're interested in is we're interested in the region that's in between there, because what happens is that 152 now is right in the middle. And what that means is the following. The shaded area is going to approximate the probability of exactly 152 yellow peas. So therefore, we would say that that shaded area then represents what we're looking for. Okay. Now, what we need to do now is we need to convert 151.5 and 152.5 to z-scores, because now we're creating the z-scale. So that means we're looking for a z-score of 1, z1, and then z-score 2. And we know that the mean of z-scores is always going to be 0 with a standard deviation of 1. So now what we're going to do is we're going to convert 151.5 and 152.5 to z-scores. So the first one, we're going to use 151.5. So if we plug 151.5 into our z-score formula, we get 151.5 minus the mean, which is 145, and divide it by the standard deviation of 10.4283. That gives us 0.623303. Rounding it to 2 decimal places gives us 0.62. So the first z-score that we've converted is now 0.62. So 151.5 now becomes 0.62. Now we want to convert 152.5 to a z-score. So if we take 152.5, subtract the mean, and then divide that by the standard deviation of 10.4283, then we get 0.719196, and rounding that to 2 decimal places gives us 0.72. And so now what we want to do is we want to be able to find the area that's going to be in between these two z-scores using StatCrunch. So let's open up StatCrunch. Now recall that in order to do this, we're going to go to Stat, select Calculators, and then scroll down to Normal. Okay, now we're trying to find the area that's in between, so we're going to select the Between part option here. We want to make sure our mean is 0, our standard deviation is 1, and then the one on the left, now let's just write this here. So we're looking for the probability that it's going to be in between 0.62, right, which is the value of either x or z. We're going to put z here since it's our z-scores, and we're looking for that probability that's in between them. So put in 0.62 here, and over here we put in 0.72, and then we're going to select Compute. I'm going to go ahead and copy this picture and the probability here. Okay, so you can see that where the graph is located is showing that it's in between those two values. Now, if we round that probability to 4 decimal places, we're going to get 0.0319, which is the area that's in between there. So, using StatCrunch, the shaded region in between the two z-scores is 0.0319. So the probability of exactly 152 yellow peas is 0.0319. Now, when we use the table, we end up getting 0.0318. So using technology gave us a value on the 4 decimal places that was slightly different than the one using the table. Now, here's the interpretation. In an earlier section, we saw that x successes among n trials is significantly high if the probability of x or more successes is unlikely with the probability of 0.05 or less. Now, in determining whether Mendel's result of 152 yellow peas contradicts his theory that 25% of the offspring should be yellow peas, we should consider the probability of 152 or more yellow peas, not the probability of exactly 152 peas. Because the result of 0.0319 is not the relevant probability. The relevant probability is 0.2676, which was found in the first example of 152 or more. So in general, the relevant result is the probability of getting a result at least as extreme as the one obtained.